Good day, everyone. The dimension of a vector space. If a vector space V has a basis consisting of n vectors, then the number n is the dimension of V, denoted by the dimension of V equal to n. When V consists of the zero vector alone, the dimension of V is defined as 0. So the dimension of V is the number of vectors in the basis. So find the dimension of each of the subspaces of R cube. Find the dimension of each subspace of R cube. So for W, we have D, C minus D, and then C. So this is a vector in R cube, where C and D are real numbers. So our representative vector is D, the second component is C minus D, and the third component is C. So we can write this down as D, C minus D, and C. It can be written as D, C minus D, C, which is equal to 0cc plus D minus D, 0. So we can collect the D terms and the C terms. So that would be D negative D 0 and 0cc. So 0cc and D negative D 0. So the two vectors that forms a basis would be 0 1 1 and 1 negative 1 0 for any vector or for any scalars C and D. So we can now say that the dimension of the subspace is 2 because there are two vectors which composed of 0 1 1 and 1 negative 1 0. You can show that this set is linearly independent. So S is a basis for W, and W is a two-dimensional subspace of R cube. So it's not necessarily N, it is a subspace. So it is of smaller magnitude. So the dimension of the subspace W can be less than or equal to N. Next, by writing the representative vector, so let's go back to that slide. So you have 2B, B, and 0. So for 2B, B, and 0, you can factor out B. So that would be 2, 1, 0, 2, 1, 0. So you can see that W is spanned by the set S equal to the vector 2, 1, 0, where B is any arbitrary constant. So the dimension of the subspace of that R cube is 1. There's only one vector that can define all the elements of the subspace. Basis test in an n-dimensional space. Let V be a vector space of dimension n. So the dimension is n. So meaning it is considering all the possible vectors. So if S is composed of the vectors V1, V2 up to Vn, this set of vectors is a linearly independent set of vectors in V, then S is a basis for V. So if the given set of vectors are independent set of vectors in V, then S is a basis for V. And if S is equal to V1, V2, V3 up to V sub n spans V, then S is also a basis for V. So if there are n vectors and it is linearly independent, then it forms a basis. If there are n vectors and it spans, then it is a basis for V. Show that the set of vectors is a basis for M51. So 5 rows, 1 column. So 1, 2, 3, 4, 5, 1 column. So these are the 5 matrix vectors. So first vector, second vector, third vector, fourth vector, and fifth vector. What we're going to do is to write this down as linear combination and check whether it is a spanning set or if they are linearly independent. since there are n vectors, since there are 5 vectors for this 5 by 1 matrix vector, so we can either check whether it is a spanning set or linearly independent. So I think it's easier to check linear independence because we are checking whether it is equal to 0. So writing it down, so you have C1 is equal to 0, 2C1 plus C2 is equal to 0, negative C1 plus 3C2 plus 2C3 is equal to 0, 3C1 minus 2C2 minus C3 plus 2C4 is equal to 0, and 4C1 plus 3C2 plus 5C3 minus 3C4 minus 2C5 is equal to 0. We're going to provide the manual solution for this one at the file section of our page. Now, since C1, from this equation, C1 is equal to 0. So if C1 is equal to 0, then automatically we can say that C2 is 0 because C1 is 0. Now, take note that C1 is 0, C2 is 0, so therefore C3 must also be 0. C1 is 0, C2 is 0, C3 is 0, so therefore C4 is also 0. C1, C2, C3, and C4 are 0. So basically, we have C5 is also equal to 0. So it forms a trivial solution. So only trivial solution exists. So it is linearly independent. Thus, it is a basis. So this system has only trivial solution, so S is linear independent. Thus, by that theorem, S is a basis for M5, 1. So that's all for our discussion today. Hope you learned a lot.